All right, well, we're going to keep right on going with our proofs, and today we're going to talk about statements and reasons for angles. So previously we talked about segments, now we're going to talk about angles. A lot of the same things come back up again. So the first thing that we're going to want to make sure we know is the angle addition postulate. And it's the exact same thing as the segment addition postulate, except it's with angles. So our statement tells us that R is located in the interior of angle PQS. So here's angle PQS, and it tells us that R is in the interior of it. Well, that means that this angle, PQR, and this angle, RQS, can be added together to make up the whole angle, PQS. So that tells us, and notice I'm starting way out here because this box is too small, the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. And you think about it, that just says that this piece plus this piece equals the whole piece. And so anytime we use that, or we want to use that in a proof, we're using that because of the angle addition postulate. Okay, the next one is one that you're familiar with. It's called the linear pair theorem. Linear pair is two adjacent angles whose non-common sides form opposite rays, or more simply, it's two adjacent angles that are on a line together. So when we see that angle 1 and angle 2 are a linear pair given to us, we know immediately the linear pair theorem tells us that that means angle 1 and angle 2 are supplementary. Okay, and that reason is because of the linear pair theorem. Well, since we're talking about supplementary, anytime we see somebody say angle 1 and angle 2 are supplementary, the very next thing we can write is that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. The reason has nothing to do with linear pairs. It has to do with the word supplementary and the fact that you know what it means because you know the definition of supplementary. Okay, the same is true for complementary. When you see something that says angle 1 and angle 2 are complementary, well, you can immediately say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees for no other reason than the fact that you know the definition of complementary angles. Okay, so definitions are important. Definition of supplementary, definition of complementary. They'll help you out in a lot of the proofs we do. All right, move back over to the next side, and we see that we have two angles, and they tell us that angle A is congruent to angle B. Well, just like with segments, if I tell you two things are congruent, you immediately know that their lengths or their measurements are equal to each other. And that's by the definition of congruent. And here we see the very next one says that the measure of angle A equals the measure of angle B. Well, that means that angle A is congruent to angle B, and that's just the kind of definition of congruence backwards. Same thing. All right, vertical angles. You know what those are. That's angle 1 and angle 3. Or it's angle 2 and angle 4. It's two non-adjacent angles formed by intersecting lines. So when we see that angle 1 and angle 3 are vertical angles given to us in a picture or in a statement, you should know immediately that angle 1 is congruent to angle 3, and also angle 2 is congruent to angle 4. You may not need it for your proof, but you should still know it. And the reason you know those are congruent is something we learned called the vertical angles theorem. Okay, angle with a little s in it. That's an abbreviation for angles. All right, angle bisector. You've learned that. Angle bisector is a ray that splits an angle into two congruent parts. That's what these little angle marks are here. These little things are called arc marks. That means these two angles are congruent. Anytime you see a statement that says NP is the angle bisector of angle MPR, you immediately know that angle MPN is congruent to angle NPR. And the reason you know that is because you know the definition of an angle bisector. All right, we just got a few more to do here. Everybody knows what this symbol means. It means this is a 90-degree angle. So if you're given this symbol in a problem or a picture, or you're told that angle A is a right angle, you know that the measure of angle A equals 90 degrees. And the only reason you know that is because you know the definition of right angles. You've known it for years, right? Also, if you ever see an angle that is given to you as 90 degrees, if it says, hey, that angle's 90 degrees, well, you know right away that that angle is a right angle. Okay, the reason you know that is because, once again, you know the definition of right angles. All right, last one we're going to do is the definition of perpendicular. See these two lines and they have this little right angle symbol between them? That means that this is a right angle, so this is a right angle, so this is a right angle, so this is a right angle. Every angle in here is a right angle, right? We don't usually draw it like that though. We just have the one, and that takes care of all four. So when you have a line AD perpendicular to CB, you know that angle 1, angle 2, angle 3, and angle 4 are right angles. Now, you wouldn't write all four of them like that for your proof. You'd only write the one that you actually needed for the step you were on, but that's not really important right now. But the reason you know all of those are right angles is because you know the definition of perpendicular, and you've known it for years. Okay? So there you go. Those are some reasons for angles. On the next page, you've got some proofs that we're going to do in class. Again, I challenge you to go ahead and try them yourself. And that way, when we're doing them in class, you're just following along and checking your work instead of writing everything I do. But that's it for tonight. See you tomorrow.